We now move on to our last panel discussion on boosting net zero emissions beyond solar and wind energy. Globally, everyone is talking about zero carbon emissions and all the countries are trying to reduce their greenhouse gases. Although renewable energy is the way to go for all, learn the new inventions in renewable energy, whether in solar or wind, and how these new technologies can help. We have Hemant Malya, Senior Program Lead, CWW, Dr. Clementine Chambon, Co-founder and CTO, Urja Development Solutions, United Kingdom, Jaydeep Malvia, Founder and Secretary General, Solar Thermal Foundation of India, Prashant Mathur, CEO, Sattvic Green Energy. This session will be moderated by Netra Walawalkar, Director, Customized Energy Solutions. Over to you, Ms. Walawalkar.
Thank you, Amrita, for the introduction, and thank you, organizers, for arranging this panel. And the topic of the session is boosting net zero emissions. As Amrita said, that this is kind of a net zero decarbonization is a buzzing word, especially at the background of upcoming COP26 summit, which is starting in a couple of days. And world has actually experienced climate change recently pretty much at everywhere. And I would say that in the last decade, it was still the kind of a discussion or debate that whether climate change is real or not. But now we all are aware that it is real and we have to take the action. Basically, net zero by definition refers to whether nations' emissions are compensated by absorption or removal of greenhouse gas emissions from the atmosphere. And as you must be aware that UK is the first country who put it into law basically to have the target of going net zero by 2050. And Bhutan is our neighboring country and they are by nature net zero because of their huge forest cover. India is not yet there to have target for net zero, but we are doing pretty much everything to reduce our emissions and having sustainable energy transition. So India is a part of Paris agreement where it was discussed to have a 1.5 degree temperature rise, limiting it to 1.5 degree as compared to pre-industrial evolution. And India has committed to reduce the emission intensely by at least 33% by 2030 as compared to 2005 level. And as we all are aware that we are taking leadership, India is the 5th global country to have renewable energy deployments. We are already at the 100 gigawatt installed capacity of renewable energy. Although in terms of energy share, we are only 12 to 13%, and we have a long way to go. And in terms of new technology, I would say that India has understood the role of energy storage technologies, which will ultimately help renewable energy to grow faster. And you must be aware that SECI has come up with 1,000 megawatt hour BESS tender, and in fact today they are going to have a pre-bid meeting about that. Other thing is India also has initiative around electric mobility and having 30% of EVs by 2030, which is also going to help reducing emissions from the atmosphere. India has a PAT scheme which talks about efficiency and reducing the actually energy consumption and thereby reducing the emissions. And other thing is not just about the electrical industry, but addressing the overall energy industry. India also has a green hydrogen economy transition, and they have a mission around it. So I am thankful to all the panelists for joining this panel. And in this panel, we will definitely try to address some of these points, mainly focusing on Indian context around green energy transition and also touching upon for some of the international aspect. So starting with the panel, I would like to invite Mr. Prashant Mathur. Prashant, you have been working with the renewable industry for a long time. And can you talk about new technologies being implemented on grid scale energy storage or grid scale renewable energy projects? Over to you, Prashant. If you can unmute yourself, Prashant.
Thank you very much, Netra, and good afternoon, everyone. So yes, solar mission is a big part of the renewable energy. Out of 175 gigawatt of renewable energy, those 100 gigawatt was solar's share, and now with the national, the Prime Minister's vision of 450 gigawatt, about 320 gigawatt is solar. So solar plays a big part. India being a solar rich country with over 300 solar days, obviously has to bank very much on solar. Now, solar obviously lot of this is dependent on the large scale utility scale projects. So India in terms of technology is very much in line with what globally is happening on the utility scale projects. So recent technologies, whatever is happening globally, is you have limited land and you want to make the most out of the installation. So earlier it used to be in terms of solar panels used to be more on the multi crystalline technology, but it has moved now to monocrystalline and then to multi busbar technology, and from P type it is now future moving towards N type. So that's more on how much conversion efficiency. So the more you convert, the more energy you produce. So these are the new technologies which are being worked on. Then India has traditionally been on fixed tilt in terms of structures which were installed, and globally they have been more trackers, and so now India is moving also towards the trackers technology, which is single tilt and dual axis, and those, so that the tracker basically means that the solar panel moves along with the direction of the movement of the sun. So that also helps in enriching more and more energy. Also, O&M plays a big part, which is operations and maintenance in a utility scale project. So O&M used to be very manual, which has now moved into robotics, and the developers now realize that proper maintenance can actually get them a lot of additional revenue, which was not looked out. And India, because a lot of these installations happens in the desert area as well, wherein there's a lot of scaling on the modules. So robotics and new technologies wherein there's less scaling on the modules are also getting it. So these are the new technologies wherein India is now focusing on to the output on the solar power plants.
And I would like to ask one more question, since you talked about actual O&M and actual this having the more conversion from the project. So could you talk a little bit about the DC to AC ratio? Because is there any limitation technically, or is there any limitation on regulatory side on having higher DC panels behind the inverter and having limited connectivity with the AC side? Could you throw little light on that as well?
Yeah, normal AC to DC ratio hovers somewhere between 1.2 to 1.4, so 20 to 40% loading. That depends on the location and the site, and obviously the kind of a PPA the developer has signed or the EPC company has signed. So it would depend on where the location is. So normally if you are in a high radiation zone, then the loading can be higher. So that's how it works.
Okay, sure. And just one more follow-up question, that when as a developer, Are there any challenges or limitations with having this renewable projects on the land or on the having the land clearance or having the connectivity? Are there any challenges that you would like to talk about that should be addressed on a regulatory or policy side? I know a lot of things are already happening in the positive way, but I would also like to ask you on what needs to be done going forward.
In terms of challenges, obviously, these scale of projects which are happening, obviously, challenges are multifold, and every project has different set of challenges, obviously. But I think the biggest challenge, obviously, is we have too much of in terms of supplies. From a developer point of view, I think it's too much of dependence on the China. I think government is taking care of it now, wherein promoting a lot of Make in India, but it will take some time. Also, there has been a lot of things which have been happening on a state side. So when you have a central policy, I think things has to happen in terms of the guarantees and all from the central government, and there have been a lot of PPAs which have not been honored, and which have backtracked because of the policy changes which have happened. There have been some really good rated government state governments with that have also kind of worked out. So when a developer invests, a project takes about 2 to 3 years to get on the ground, and if there is a policy change that happens, obviously that really affects the developer, and their financials get spoiled. So I think that is something which needs to be worked out, and obviously financing is another issue. So financing, and so that challenge continues. So that is also one of the big factors.
Yeah, sure. I would say that there was a really good discussion happened in the previous session, which I attended on the financing, and some of the points have been addressed there. So we talked about the large-scale renewable projects, and moving on to the small scale now, we have Dr. Clementine. And congratulations, Clementine, on closing the round of seed funding for $1 million by Schneider Electric. I read it about it I think it is a very recent update. So you are working at the very grassroots level and helping rural areas in getting access to renewable energy and having those certain agriculture applications on the renewable energy. So how do you see the response from the community for such projects, Clementine?
Yeah, thanks a lot, Netra, for the shout out. And yes, so just first of all, yeah, thanks for the opportunity to be here. And I'll just briefly introduce what we are actually working on. So what Urja Development Solutions is doing is, so we're a mission-driven company. We operate in rural parts of the country. Right now we're focusing on northern states. And we work in the off-grid decentralized solar sector. And specifically what we have been focusing on is getting access to solar technology in the agriculture sector. So if you look at the user profiles, around 87% of farmers are small and marginal, and they're still very dependent on fossil fuels. And this is actually one of the big contributors to, the agriculture-related greenhouse gas emissions is this use of diesel fuel, which is used mostly in the primary stages of agriculture. So for things like irrigation, and then for things like agro-processing, post-harvest processing, and then across the agricultural value chain. So what we're doing is we're working in these areas where farmers are reliant on these diesel motors, mostly for irrigation. And we're providing them solar technology as an alternative. But now the challenge is, even though solar costs have come down by about 80% in the last few years, but they're still not affordable to the majority of smallholder farmers. And that's despite the fact that there is capital subsidy, for example, through the Kusum scheme, where farmers can get between 60 and 90% of the capital cost of, for example, a solar pump can be availed through this scheme. But that leaves the 10% upfront cost, which they have to bear. And if you take a typical example of a 1 HP solar pump, so that's sufficient to irrigate a few acres of land, already bigger than the average land holding of at least the farmers we work with tends to be less than an acre. You're looking at least an upfront capital cost of around 10,000 rupees. So it doesn't sound, huge, but that's already a major upfront cost barrier that most farmers can't bear. So this is the problem we're addressing, is the high upfront cost barrier. And if we don't overcome that, then even though we have myriads of technologies that are available to solve the climate crisis, they won't be adopted by the people who really need them. And we won't make any progress both on our climate targets, but also on other targets, because we have to remember that access to energy is fundamental for powering jobs. It's fundamental for, promoting livelihoods. And that means, for better quality of life as well. So what we've been doing is turning solar into a service where our company invests in infrastructure and then we make it available to farmers on a pay-per-use business model. And we're seeing really good results. So just staying on the solar pumps as an example, if a farmer moves from a diesel-based pump to a solar pump, they can really reduce their cost of irrigation by around half. And that 50% reduction, they can, that's a direct input saving. Then they can also irrigate more reliably. They can increase their crop yields, and it provides them a more predictable source of income. It also builds resilience to, climate disasters and helps farmers actually adapt to the effects of climate change. So yeah, the response has been very positive. We're working with about 3,500 people at the moment who we've been able to reach through about 35 decentralized solar projects. And we found that this, our model actually relies on employing people from the villages who we train as operators. So that also creates local employment. And during the first and the second lockdowns, we've been able to actually employ returning migrant laborers as our operators. So yeah, this last mile job creation, I think, is another aspect of, solar technology that can create a lot of change. And just finally wanted to add that we're also seeing it as an avenue for pushing up the economic participation of women, because around 80% of the economically active women in India are in the agriculture sector. So if we can develop their skills and help them become part of this solar, technology and the operations and maintenance of that, we can create extra income for them and their families, and that will have an even more widespread impact.
Yeah, this is really important to have that local buy-in from the community for such projects, because these projects would be in a remote location. So unless you have that interest from the local community and they really see that unless their own involvement is there, I guess it will be difficult to have successful implementation of such projects. And you talked about women involvement. So I would like to also share one quick experience of ours that we have actually installed one smaller microgrid based project for the tur dal milling in Jharkhand, and it is creating that local employment with the women. And important, the way women are involved and taking the interest and showing the initiative to come forward and get trained for that, that is really impressive. So talking about the new technology then these solar projects, are these with the energy storage technologies? Do you use lead acid batteries for this with the solar panels? Could you talk a little bit about that as well?
Sure, yeah. So it depends on the application. In the case of the work we're doing, like I said, it's solar for agriculture. So we focus on 3 different verticals at the moment. One of them is irrigation. So the others are solar milling, and the third is solar cooling. So in the first 2, which are more technologically mature, so solar pumps are pretty mature, these are directly powered by solar, and there's no storage component there. So there's no lead acid battery required. It's just a PV array, obviously mounted, ground mounted, and then either submersible or a surface pump. If we were to add storage in that kind of situation, it would just increase the cost of the installation, which, like I mentioned, is already a big barrier, and increase the cost of irrigation, obviously. So, that's not actually commonly done. What you would see is storage of water. So you might have a storage tank, and then that could be distributed. On the milling side of things, so there again, it depends. In our systems, we don't actually use storage either for the milling. So it's powered by the sun when the sunlight is available. Now, again, it's a cost, and it's a techno-economic question, whether you want to add storage and then increase the levelized electricity costs that you get, and whether that still becomes, economically attractive. Then you have to look at the cost of milling, the alternative cost of milling from diesel, for example, and then compare it. In our case, again, we've chosen not to. And where we have used storage is in solar cooling. So there we've been working with manufacturers that actually have phase change materials. So you actually have thermal storage, not electrical storage. So that these are systems that are actually hybrid, like they have power from solar, but they also have backup power from the grid. And then that's used for, there's a thermal storage there so that when neither source is available, then you're still able to get cooling power. And that also minimizes the environmental footprint, because as we know, lead acid batteries are, not ideal at all from an environmental perspective. We've also been trying to move towards alternative storage technologies as well, where they are required, and definitely trying to minimize the storage capacity in our systems.
Definitely. So as we are talking about decarbonization and this environmental benefit, we have to also keep track of the cost of the technology and how exactly it can be implemented for various applications. So actually moving forward with this, we can touch upon another technology. So Mr. Jaydeep, you are co-founder of Solar Thermal Association, and although we see a lot of discussions around solar PV, solar thermal is very less talked about. So could you provide more insights on the system and their applications here?
Thank you very much. Good afternoon to the audience and the organizers for providing this opportunity. I am Jaydeep Malvia, the founder of the Solar Thermal Federation of India, which is now a 12-year-old body, and I am also the Secretary General. As rightly pointed out by Dr. Netra, today solar PV has taken the center stage, where, there's another part of the solar also, solar thermal, which has perhaps been forgotten. But just for the benefit of all the audience, that India today is the third largest solar thermal market, where, we should pat on our back. And let me tell you that there was only one target announced when the first national solar mission was announced in the year 2010 to achieve 20 million square meter by the year 2020. But we achieved much faster than that. In fact, we achieved it 2 years back. And see, solar thermal has a direct relationship with your carbon footprint, because eventually it helps abate your fossil fuel when we talk of generating heat through solar thermal. There were two major programs that led to a kind of, I would say, revolution in India. One was by the United Nations Development Program, UNDP, on accelerating solar water heaters, and then subsequently the solar thermal in industries. And after that, UNIDO came with another program with some kind of an interest subvention, providing low-cost financing to industries who look to adopt concentrated solar thermal systems. So these two programs did provide sufficient impetus to this sector. However, you see, today, if you talk of solar thermal as far as India is concerned, we are the second largest solar water heater market, which is largely used in the residential and domestic sector. And believe me, it has hugely benefited the electric utility companies as demand side management. Unfortunately, it has perhaps been ignored by the policy makers. It could have been done mandatory all over the country, barring few states where they made it to, address this demand side management situation to improve the power scenario. As far as the industries is concerned, India is amongst the top 10 industrialized countries. And for your information, 70% of our industrial heating is based on fossil fuel, which we are importing. And that needs to be given a serious thought. Just the way, the government thought of, go to electric mobility, because that's the sector which ends up consuming fossil fuel. Let me tell you, it's not transport, it's the industry still which consumes the highest amount of fuel. And today, for the government, the highest burden is, import of fuel. I'm sure there is a huge potential in India. We did a couple of studies equivalent to some 6.5 gigawatt thermal is the potential in industries to meet heating up to 150 degrees, right? And recently we completed one study funded by the German government. The project was called as Solar Payback, wherein the study required to identify those industry segments where solar thermal heating can start off. And then subsequently it can percolate down. So we identified, the dairy processing. India is, world's largest dairy processing, by the way, in the world. We have a target of 108 million metric tons of dairy processing. And at multiple processes, dairy ends up using heat. And here is where it's we can meet our whatever you can say the INDC we have set up just through solar thermal, integrated nationally determined contribution. Of course, solar PV is greatly contributing, followed by wind. But that's one sector, followed by food processing, pharmaceuticals, and textiles, and a brewery, and then automobile component. So there is huge potential. It needs probably more awareness in industries. Of course, the domestic sector has realized the advantage of solar heating. Let's not resort to solar PV heating. Often people think, I use electrical form of heating, so can't my PV meet? And that's where, probably some confusion has been created yet. So we are a country where traditionally, practically every Indian takes a hot water bath. And I'm sure that it could be in a sustainable form. The technologies today are pretty much affordable. They pay back within 2 years. You don't need any subsidies, nothing. So that's it as far as solar thermal is concerned. Unless I'll come back later. Want on the circular economy later then.
Yeah. So thanks for throwing more light on this solar thermal, and it is interested to know the potential you talked about is around 6 gigawatt in India, and I think very little has been tapped so far. And you briefly mentioned about different industry segments where it can play a role. Now, on that front, coming to the next topic kind of a thing, where a lot of real estate developers, having the independent buildings, maybe from the request from the multinational companies, they're willing to go for the green building. And there is a green building initiative by CII, and there are a lot of things happening. So could you talk a little bit about how exactly buildings can go for that green building kind of status, and should it be from the start, or even the existing buildings can go for green building status? Okay,
good question. See, the Energy Conservation Building Code, which was drafted first in the year 2012, followed by amendment in 2017, and the last amendment was in 2019. It very clearly stated that 20% of the energy needs must come through sustainable sources. Now, every building cannot have a wind, right? A bio could be an option, but the most attractive and probably the most easiest is the solar energy sector. And within that also, they had mentioned that the heating needs must be met through solar thermal. Okay, now having said that, a Green Building Council already exists, and it requires some kind of, I believe, a further education on this, because people are caught in two minds. If I have to declare my building green, have I to first consider solar photovoltaic, or I should also have a solar thermal component in that? Right? As far as that is concerned, if I've answered, yes, green building is possible, but let's not think of having 100%. It starts right from the architect, I would put. I'm very sorry to say, but I blame the architects. They are not following the norms that facilitate buildings to have solar systems put on them. Because, these have to be in a particular direction to capture maximum sunlight. They have to be shadow free. And unfortunately, these design considerations are not taken in mind. And as a result, what happens, if a building has to go to be rated as a green building, they cannot fulfill it. Then you have the other option of using passive structures, of course, you can do that. But certainly, I feel that the starting point or the foundation are the architects. They need to be told about it. If they can start implementing the designs that facilitate any solar system, I'm sure we will be able to achieve the green building targets.
Sure. And talking about this sustainable energy share of 20%, so many multinational companies even do have that RE100 kind of a vision and target. And I would like to add to that, in India right now, the open access eligibility for consumers has been 1 megawatt contract demand. But the recent Green Energy Open Access draft talks about even 100 kilowatt contract demand consumer can go for the green energy, and that way they can avail the green energy consumption. And there will be some more clarity required, but we are on that right path to have lot of green energy available even for the commercial industrial segment. So we have been touching upon this large-scale projects and even rural electrification from the green sustainable energy. We talked about this commercial industrial consumers, but net zero is a very vast subject, and internationally it has been looked at in a different way. So I would like to invite Mr. Hemant Malvia, and Hemant, you are working specifically on industrial decarbonization. So talk about the big picture of the net zero movement and what are those global practices that are being considered for net zero targets and net zero status.
Sure. Thank you, Netra, and good afternoon to everyone. Thanks for having me on the panel. I think net zero is the buzzword that we should be talking about. COP is right about to get started. As of today, I would say about 130 odd countries have signed on to net zero, and just for those who are uninitiated into the terminology, net zero doesn't mean that you have zero emissions. Net zero means that on a net basis, even if you have some amount of emissions, they are offset by some kind of sink, be it your own facility or somewhere else. So that's the concept of net zero. So about 130 countries have already signed up for net zero. They have made some commitments that they will reach net zero usually around 2050 is the most talked about year, but China is going as far as 2060. And now these 130 odd countries represent about 70 to 75% of the total global emissions, right? And so it might sound like a very promising next step. However, if you unpack the announcements a little bit, you'll find that very few countries have actually taken the next step of formulating the policy into some kind of regulatory requirement, right? So the UK has done it, Sweden has done it, but the big emitters like the US and China have only made policy announcements. There are no roadmaps. There are no specific regulatory measures to actually achieve net zero. So that's significant because I think it's important to understand some of the legacy commitments that have come in the past, and that's where we find ourselves in the global conversation as far as net zero is concerned. So what CW has done is we have analyzed the Kyoto Protocol commitments and the subsequent Doha Agreement commitments, and what we have found is if you look at the developed world, the target was somewhere around 18% reduction, but then what was actually achieved was only 15%. But if you unpack it further, you'll find that of the developed countries that have achieved 15%, roughly reductions from the 1990, emission levels, and then you take out the former Soviet Union countries, the net reductions from the remainder of the developed world has been a meager 3.7%. So from the 1990 levels, the developed world has only reduced about 3.7% emissions. Now that's very important because that's the backdrop, that's the trust deficit and the credibility, or rather the lack of credibility, that we are going into COP26. That's where net zero stands as of today and where India finds itself. Having said that, what is different from what has been in the past is industry has started making commitments on their own. So in the past, it was up to the countries to formulate mechanisms which will result in those reductions. But it's now the industry that is taking the lead, and therefore the possibility of action and credible reduction is much higher because of the industry participation. Now, having said all of that, if you look at India perspective, we can actually look at net zero as a strategic opportunity because most of our energy is imported. We import 85% of our crude oil, 55% of our natural gas, and about 25% of our coal. So if you look at 2019-20, we imported about $140 billion worth of energy. So from our perspective, it's actually a strategic advantage to look at green energy and not get distracted by the net zero commitment necessarily. Of course, there are huge challenges, but that's kind of the context in terms of net zero that we are looking at.
Yeah, sure. And as you rightly say, India can look at it as an opportunity where we can focus heavily on the green energy, which can ultimately reduce our import, and that way we are moving a step or ahead towards the sustainability and reducing emissions. You briefly talked about industry taking initiatives. Even the nations are not yet ready on a national level. So in the Indian context, if any multinational company or any organization is willing to go for the net zero path, so what is that first step to actually benchmark? What is their footprint? So can you talk a little bit about how this footprint is calculated for any organization?
Sure. And I must say one thing that we don't believe that decarbonization is a binary, because often the discussion goes between either you are an emitter or you have committed to net zero. But we feel that there are many incremental steps that can be taken that can achieve net zero in the longer run. But the thought process has to change, because then you can't plan for it accordingly. Now, having said that, to achieve incremental emissions, it's important to understand where the emissions are coming from. You can't manage what you can't measure. That's kind of the basis on which reductions can happen. So in India, in the past, inventories have not been a very common practice. Much of the assessment on how much we emit has been based on how much fuel is overall consumed. Now, that's an easy metric to begin with, but that's not very helpful when you have to plan reductions. And there we need to understand where are the emissions coming from at a process and equipment level, because it's only then that you'll be able to identify mitigation options and deploy them, to effectively reduce emissions. Now, as far as benchmarking is concerned, I think, the BE has done a little bit of a benchmarking, and I say little bit because the primary focus has been the PAT scheme, perform, achieve, and trade. But those, facilities that were a part of PAT have been the large facilities, but much of the energy is also consumed in the small, medium enterprises. In fact, SMEs consume about 30% of all the industrial energy. So therefore, there is a lack of understanding of where the emissions are coming from. And we could always use international benchmarks, which is what is commonly done. However, that's not very effective because, technologically we may not be in the same place, as well as, the type of energy we consume, right? So for example, the cement industry in India, consumes a lot of petcoke, but, if you were to use a US benchmark, which uses a lot of, natural gas as well, the comparison wouldn't be apples to apples. So it's not very effective. So I think the first step is, inventory development. And there are several protocols out there, some really good ones at a national level. For example, the US, EPA greenhouse gas reporting program, which has very prescriptive measures on calculating or measuring emissions at a process and equipment level. So, companies can always utilize those protocols. And then there is something that we have been already doing, not so much on the greenhouse gas emission space, but more on the air pollution space, where the Central Pollution Control Board requires several industries to install continuous emission monitoring systems on their stacks. So those SEMs already exist, and a little bit of an upgrade and tweaking would allow you to actually measure emissions that are coming from your facilities, and those are fairly accurate. So those are mechanisms that can be used. Of course, like I said, there are international benchmarks that can be used to at least get started.
Sure, yeah. So we will come back to again this topic later, but again going at the start that about the renewable energy penetration in India. So although we have 100 gigawatt installed capacity right now, our in terms of energy share, renewable energy is only 12 to 13%. And although having must-run status, renewable projects are facing some problems with curtailment. So I would like to again invite Prashant to talk about what are the challenges in terms of operating renewable projects, and how do you see how we can fast track that share of renewable energy in terms of energy in the mix of India's grid.
So currently the renewable energy share is around 20%, and solar share is only 6% of our total energy produced, which is very low. And in the focus on renewable energy now is to increase that share at least to 50%, and solar has to play a big part there. I think the most important part to increase that is, and to decrease our dependence on thermal. And what government has already done is that new thermal, not coal, not solar thermal, but coal based projects which I'm talking of. Government has already started, no new projects are being announced for coal thermal. So now we have to move towards renewable, and I think the first and most important is that manufacturing has to happen in India, because we have too much of dependence on China. So that is first and foremost, and the government has already started that PLI scheme and basic custom duty also, and ALMM. These are some of the steps which have been taken by the government to promote manufacturing. So once you manufacture in India, obviously, you're not, as of now, what has been happening is more 90% of the solar has been coming from China. So we are basically running Chinese industry based on the renewable success which we have been building in India. So I think that is one and the foremost. Then the other is the policies have to be clearly ironed out. Now that these policies have come in, but still the policy implementation on ground has not been at that pace which should have been done. So adoption of renewable energy will happen based on how these policies get implemented. Apart from that, utility scale projects, if we see, India wanted to do 100 gigawatt, only 50 gigawatt has happened by 2022. So we are still a large gap is there between what was announced and what has been implemented. But if we see, most of it has actually come from utility scale projects. So rooftop had share of 40% and utility was 60%, but 40% rooftop has not happened. And so that 40% rooftop or 40 gigawatt rooftop actually has only 4 gigawatt has happened. So a lot of potential on rooftop is there. I think proper education also is not there. People are not aware that solar is one of the cheapest form of energy now, power, and there has been a lot of policy changes, CEIG approval, net metering, cross metering, and all those. Every state has been running their own policies, and a lot of bureaucracy has also played its part in slowness of the implementation of that. There have been some for example, Kusum scheme for rural be it component A, component B, component C, pumps and all that, which is part of Kusum scheme, is a very good step. But on the ground, installation has not happened because those projects have not been, they are not in, banks are not ready to fund those kind of projects. So I think all of these needs to be ironed out properly, and that's how renewable share will increase. Apart from that, currently, though solar share is only 6%, but per capita energy consumption in India is one of the lowest in the world. We are per capita energy, we are not even consuming 1,000 units compared to China is 5,000 units. US is 12,000 units per person. So we have, one is to increase share, but itself the pie is going to become much, much larger. So we are, as the country is developing, our energy needs are going to go up by 4 to 5 times in next 10 years, which is also huge. So renewable energy has to play a big part. So well supported by, things on the ground.
Sure. Yeah, and as we are talking about this huge penetration of renewable energy, I would like to also touch upon the point that at the end of the day, it is an intermittent energy. So when we are complaining that discoms are not signing the PPAs, because there is some difficulty for the state load dispatch centers to schedule that energy, how to balance that generation and demand. That is one point. And although solar has a great potential, solar is available only during the daytime. So if we want to move that solar to the evening peak hours where the demand is also high and the tariff is also high. So in terms of, as we are talking about the new technologies in this session, I would like to touch upon this energy storage, because energy storage is going to play a critical role not only on the generation side but also on the distribution side. While we are talking about the behind the meter rooftop solar projects, where again why discoms are hesitant with the net metering, because they are absorbing that energy when they do not need it. So how to tackle that situation? So having the right size energy storage technologies at the generation, distribution, which is going to also help in the ancillary services, frequency management. So all, I think definitely it is going to help grow renewable faster in India, and with the current development from the Ministry of Power, we are at the right track. DHI has also announced PLI scheme for advanced chemistry cell manufacturing in India. So PLI scheme for solar as well as ACC manufacturing, if they go hand in hand, eventually in near term, India can be at the much better state in terms of dependency on the foreign fuel. Now, again, moving to Clementine, although we talked about a lot of big projects, as you rightly said, even on the agriculture side or remote rural side, the projects are very small in size. They are very large in numbers. So ultimately, the impact is going to be considerable. So for your organization, what is the outlook for you for maybe by 2025?
Good question. So, I mean, I guess, we're looking at the agriculture sector, we have an energy focused lens at the moment, but we're looking more at our impact in terms of transforming the agriculture sector, which of course has a huge contribution to greenhouse gas emissions. I think about 18% of India's greenhouse gas emissions are from the agriculture sector, but it's also a sector that's hugely impacted by climate change already today. I mean, I don't need to tell you how disrupted, climate patterns have already become. And of course, that's, having an impact on farmers. It's also going to have more and more of an impact, very worryingly, on crop yields at a time when we need to actually be increasing the output per, unit of land, but without further, worsening the environmental impact that the agriculture sector already has. So, I mean, there's a lot of things that we can say about this, but to sort of be a bit succinct here, if you look more generally at the agriculture sector, I believe that a lot of the emissions actually come again from this primary stage and from a few different things. One is from, overuse of fertilizer, which is, hugely polluting, but also, obviously very energy intensive to produce. Then it's to do with the way that we manage soil and the way that we manage land. So, and then the third is to do with, the excessive uses of groundwater as well, which has an impact for the fossil fuel side of things, but also, of course, for the groundwater levels. So I believe even if we could, address those three issues, the fertilizer, and then move towards zero tillage or similar techniques and manage how much water we use, especially for paddy, that would already have a big impact on reducing the greenhouse gas emissions from the agriculture sector. And I think it's important to emphasize as well that moving towards sustainable agriculture doesn't only come from new technologies like solar, for example, but also from, traditional or ancestral techniques that farmers used to do or already know about but have moved away from. So, for example, using local resources in agriculture instead of excessively relying on chemical inputs, for example, through zero budget natural farming, that is one way that farmers can, move towards sustainable agriculture. So how do we actually achieve that? How do we achieve this transformation without, impacting the crop yields and without increasing the carbon intensity of agriculture? I think the key is to do with enhancing the knowledge and the skill that farmers have, because if they are equipped with the right knowledge, the right services, access to goods, then they can do this for themselves, because obviously they have their own vested interest in increasing their own crop yields, and that will have an impact, on the carbon side of things as well. So as always, because we're also talking about a population, in the case of small and marginal farmers who make up most of the farming population, who are very economically vulnerable, so we can't just look at climate change, on net zero emissions through that. I mean, we have to take a much more holistic approach than that. So what we, our organization, UJA, are aiming to do, the part we want to play is to become a platform that can provide farmers with the essential agricultural services that they need to increase their income and also their quality of life. So we're doing that first through an energy lens, but we will then also try to expand our portfolio and bring other services on board, some of which may be digital, some of which may be offline, to provide them with the knowledge and the goods that they need to be able to do that.
Yeah, and that is very important. And I'm curious to know, Clementine, in which states your projects are right now? I mean, which states you are focusing on right now?
So as I said, we're focusing on the areas where farmers are most reliant on diesel for groundwater consumption, but also for milling. So we're working in the weak grid states, mostly right at the moment we're in Uttar Pradesh and in Bihar, but we see this. We want to scale in other, in eastern states as well, where farmers have similar, reliance on fossil fuel. So there's a few different factors that we use to select the geography. Some of which are geographical, some of which are more related to the type of farmer profiles as well, because we specifically target small and marginal farmers, and some are to do with their energy consumption patterns.
Good to know. So moving next, as we are talking about a lot of renewables, and solar PV has a kind of a already big scale of installations in India, and will be coming up with more and more solar PV projects in India. So I will come to Jaydeep talking about kind of a circular economy, that you promote that topic pretty much, and that is important. Because as we are, I mean, a lot of solar projects are already at the age of 10 right now in India, and going forward in maybe in next 5 years, there will be a lot of such sites where solar panels will be up for the replacement. So how do you see the role of recycling activities playing role in this net zero equation?
That is going to be a $1 million business in future. Take my word, you rightly put it up. Before that, there are two things I just want to touch upon. One is, that perhaps also we are ignoring the energy efficiency part. We are talking a lot of renewables as far as net zero or achieving zero emissions are concerned. I think that portion has been rather sidetracked. Just if we take a couple of years back, energy efficiency was more thrust upon. If we even do that, I'm sure we will be able to increase our renewable energy component if our practices are best. I just thought I'll share on that. As far as the rooftop is concerned, I fully agree with Dr. Prashant Mathur, but let me tell you that, the intent was there to achieve this much amount of rooftop, whatever 40 gigawatt or something, but it need not necessarily we should chase that, because as grid connected solar power is becoming cheaper, what we foresee is, or rather I foresee is that, rooftop may not become too attractive option. It would only be that, yes, you can offset certain amount of your own power individual for which they may attract. Now, just this observation, but having said that, yes, you see, as it was pointed out that we as a country are largely dependent on a neighboring country as far as the inventory is concerned. Largely it comes from there. Now the government has already shown intent under PLI to go Atmanirbhar, which will require huge amount of metals to be extracted if we have to. Correct. Now, one of the options which we can fulfill is, why not reuse the solar energy assets which will achieve the end of their life by reclaiming all the components within, whether we talk of the aluminium, the glass, and then of course, these two almost constitute 80% by weight. And then there are, of course, silicon, silver, copper, and whatnot. And it's doable. These are challenges. Now, what probably is happening, globally, they are insisting on solar recycling more from the environment point of view. All right. It is rather, more prudent if we say that, can we reclaim the materials so that we reduce our dependency and reduce the mining, thus address the carbon footprint. So I'm sure that recycling is going to become a huge business in future. The other aspect to that is that, as a country, we do not have sufficient resources. Still, we have to import, whether you talk of copper or even, the aluminium. So here is something that we can reduce our dependency on import if we reclaim back these components. The challenges are definitely there. A lot of R&D needs to be done. The government needs to focus on it. And we are sure that almost 95% of these components can be recovered. The policy has to be there in place. Unfortunately, there's no policy on end producer responsibility, the EPR we are talking of. If we can have that in place, then why not? Even, in the storage part, the batteries can be recycled, the inverters, of course, batteries under waste management, inverters form part of the electronic waste management. Unfortunately, there's nothing for the solar panel, and this is going to create huge jobs. And the challenges ahead, how we recycle these equipment without damaging the environment. So certainly, this lays the foundation for a future prospects of new business.
Sure. Thank you for pointing this this new opportunity. And as we are at the kind of end of the session, I would like to go to Hemant and again ask him to briefly touch upon the green hydrogen part of the energy system in terms of when we are talking about the net zero. Because although electricity plays certain portion of the overall energy, there is another sector where green hydrogen is going to play bigger role in manufacturing or petrochemical agriculture as well. So Hemant, over to you.
Sure. So, green hydrogen definitely is promising in India. If you look at green hydrogen or hydrogen in general, there are two pathways that we can talk about. First is, where the hydrogen is being used in legacy processes, and primarily there are three, so refineries, fertilizers, and methanol production, they all use hydrogen as feedstock. So all you have to do is replace the gray hydrogen with green hydrogen, the easiest to done, supposedly. And so we are looking at around 5.6 million tons of, potential there as far as legacy hydrogen is concerned. And then, of course, there are upcoming areas where hydrogen might find, some utility. Of course, there is the mobility space. So we estimate that, around 24,000 vehicles might be on the roads in the next decade or so, primarily in the heavy duty vehicle space, and some of it in light duty. But the volumes there aren't significant. And then of course, natural gas blending. So something that is being talked about in the natural gas based economies, something that we can explore as well. In fact, I think the government has indicated interest. NTPC is going to try out blending in Gujarat. So there are opportunities there for blending, but there are limitations there because the infrastructure that we have for natural gas today cannot handle more than 15-20% blend of hydrogen. It requires a different grade of steel or a specialized lining, which we don't have right now. And then of course there is the steel industry. So primarily today steel is made using coal, but there is potential to replace about 15-20% of the energy in in the process with green hydrogen. So there are these opportunities. We think around 10 million tons per annum is possible in the next decade. But having said that, there are several challenges as well, and I think Jaydeep touched upon it briefly. So if you have to manufacture electrolyzers, we do need critical minerals. We need the iridiums and the platinums of the world, which we don't have access to. Technology is also constrained. A certain kind of electrolyzer known as PEM, proton exchange membrane. 40% of the cost of a PEM electrolyzer comes from a membrane that is made only by one company, DuPont, in the world. And so there aren't any alternatives as of now. So technology is also constrained. And finally, resources by itself, right? So if we talk about resources, it means land, it means water, it means how much capacity of renewables we deploy. So just to give you a sense of scale that is required, let's say if we have to replace the 110 million tons of steel that we produce annually, in the more recent years, if we have to green it all using green hydrogen-based green steel, we would need about 265 gigawatts of solar capacity, water equivalent to 7% of Gujarat's consumption, also actually 16% of Gujarat's water consumption, and 7% of Gujarat's land. So that's only for steel. If you have to then decarbonize the other sectors, you're looking at literally thousands of gigawatts of renewable energy. So although it's a promising opportunity, it has to be seen as a part of the solution, not the be all end all silver bullet. And then finally there is the finance aspect. Again, going back to the steel example, if you have to make all of our steel green, we are looking at a capex of around $330 billion. And that's only the existing capacity. We intend to double our steel capacity in the next decade. So again, $1 trillion+ of investment. Where is the finance going to come from? And this is something that will be seen globally. It's not just us who are trying to decarbonize. It's a global phenomenon. So capital definitely is going to be a big challenge as far as green hydrogen economy is concerned. So some promises, but if done well, certain areas will have more opportunities than others.
Sure. Thank you for sharing all those details, and all those numbers are really astonishing. But I would say instead of getting overwhelmed by the numbers at the kind of 100%, maybe we can definitely go step by step. And Niti Aayog, I know, have very much have focus on working on this green hydrogen mission, and eventually we will go there step by step. And this net zero is very challenging, but it is at the same time important. Climate change is real, and it is definitely time to take action. And as an industry, as an energy, transportation or manufacturing, these kind of industries should definitely start taking those steps immediately so that we can go eventually reach to certain point. So any final comments, or I would like to ask organizers, are there any questions for the panel? So, as I said that although there could be long-term goals, we should think about the short-term goals as well and make sure we achieve and move forward with this net zero, decarbonization, sustainability aspects in every way. So thank you, and back to you, Amrita.
Thank you, everyone.
I thank our panel members for taking out time from their busy schedule to enlighten us with industry insights. Thank you.